Hello, dear students. Let us to discuss some terms which are remained in laws of motion. So, before the discussion of the terms, first of all, once again we have to discuss the very important terms, that is inertia. Inertia is that state of the material of the body by virtue of which the body cannot change by itself. It's a state of rest or of uniform motion in a straight line. So this one is called as the inertia or inertial property. Okay. So Newton's first law. So this Newton's first law is also called as law of inertia. So this Newton's first law of motion, which is stated that every body preserves in its state of rest or of uniform motion along a straight line unless compelled by an external force to change that state of rest or of uniform motion along a straight line. Okay, so just we have discussed that is this second law is also this first law is also called as the law of inertia. So the meaning of the first law is without force we can't change the state of inertia, or if you want to change the state of inertia, force is essential. Okay, now let us to discuss the term momentum. Momentum means quantity of motion, and this quantity of motion that can be measured as the product of mass and velocity. And this momentum is a vector quantity, and its dimension is m l t minus 1, and the SI unit is kg meter per second. Okay, so these are the some important terms. See in this picture, this one is because of law of inertia. Law of inertia. Okay, so without force it is not possible to change the state of inertia here. So the motion cannot be changed without force. Okay, yes, we go for next one is Newton's second law. This Newton's second law, which is stated that the rate of change of momentum of a body is directly proportional to the impressed force and take place in the direction in which force acts. Rate of change of momentum proportional ಆಗಿರುತ್ತೆ ಇದಕ್ಕೆ applied force ಗೆ. So clearly F is proportional to dp by dt. See, or F equal to some constant into dp by dt. Okay, let that proportional to constant, we can say it is K. K is the proportionality constant. Okay, here momentum is changing. Let us to consider we can change the momentum by changing the mass, by changing the velocity, or by changing the mass as well as velocity. So let us to discuss the momentum is changing just by changing the velocity. Okay, so it means mass is constant in this case, and we can discuss the rate of change of momentum. Okay, see, dp by dt means d by dt of mv. M is constant, so only the velocity is changing. So the rate of change of momentum means rate of change of mass into velocity. Mass is constant means rate of change of momentum means mass into rate of change of velocity. We have already known the rate of change of velocity is acceleration. So therefore k equal to or f equal to k into dp by dt, and that dp by dt is ma. So we can write f equal to k into ma, where k is the proportionality constant. Okay, so now let us to define unit force. Okay, so note down this carefully. Okay, so what is this unit force? Unit force is the constant force which acts on a body of unit mass produces unit acceleration. ಯೂನಿಟ್ ಫೋರ್ಸ್ ಅಂದರೆ ಎಷ್ಟು ಅಂದರೆ ಆ ಯೂನಿಟ್ ಫೋರ್ಸನ್ನು ಯೂನಿಟ್ ಮಾಸ್ ಮೇಲ್ಗಡೆ ಹಾಕಿದಾಗ ಯೂನಿಟ್ ಎಕ್ಸಲರೇಷನ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದರೆ, ಸೊ ದ್ಯಾಟ್ ಒನ್ ಈಸ್ ಯೂನಿಟ್ ಫೋರ್ಸ್. ಸೊ ಎಫ್ ಈಕ್ವಲ್ ಟು 1 ಅಂತ ಯಾವಾಗ ಕರಿತೇವೆ ಅಂದರೆ ಎಮ್ ಈಕ್ವಲ್ ಟು 1 ಮೇಲ್ಗಡೆ ಆ ಎಫ್ ಈಕ್ವಲ್ ಟು 1 ಅನ್ನು ಹಾಕಿದಾಗ we are getting a equal to 1. So simply by substituting the values of f, m and a, all 1 1, so we are getting the value of k as 1. The value of k is 1 means the above equation, that is f equal to k times ma, we can write it as f equal to ma, that is force equal to mass into acceleration. Clear? Okay, so now we can discuss very important concept, free body diagram. Most of the competitive examination you can see such questions on free body diagram. See, here there are two masses m1 and m2, and these two masses are tied with the help of rope or thread, okay, and placed over a frictionless pulley. If m1 equal to m2, then definitely both masses are equilibrium. If m2 is greater than m1, then definitely what happens, m1 will be accelerating down, m1 is accelerating up, and m2 will be accelerating down. Okay, so in this case m2 is greater than m1. So here one thing you have to remember, these two masses are tied or attached with the help of rope or thread. So whatever may be the acceleration of m2, m1 is also having the same acceleration. Only the direction of the acceleration are opposite, means m1 is accelerating up, m2 is accelerating down. Okay, So here T be the tension. What is the tension? We have already discussed. Okay. So now we can write the free body diagram, means all forces that will act on the mass m1. Okay. Here carefully you have to observe. Here the net force is m1a on first mass m1, but m1z that will be acting down, and tension T is pulls the body in upward direction. So T is greater than m1z, and because of this effect the mass m1 is accelerating up. So T minus m1z equal to ma. We can write the free body diagram for the first mass m1. ಆಯ್ತಾ? ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ m1 ಮೇಲ್ಗಡೆ ಎಕ್ಸಲರೇಟ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಏನಂತ ಬರೆಯೋಣ? T minus m1c equal to m1a. Similarly, we can write the free body diagram for the second mass m2. ಇಲ್ಲಿ m2 ನೋಡಿದ್ರೆ m2 accelerating down. T1 pulls the body m2 in upward. So definitely m2z is greater than T. So therefore we can write m2z minus T is the net force, and that net force is mass into acceleration. So that is m2a, and we can call this as equation number 2 and previous one as equation number 1. See, ಇವೆರಡಕ್ಕೂ ಆ್ಯಡ್ ಮಾಡೋಣ. ಇವೆರಡಕ್ಕೂ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? m1z, okay, m2z in second equation ದಲ್ಲಿದೆ. Just by adding tt that will get cancelled. m2z minus m1z equal to m1a plus m2a or m1 plus m2a. So therefore a is m2 minus m1 into z divided by m1 plus m2. So by substituting the value of a equal to m2 minus m1g divided by m1 plus m2 in any one of the equation, and by simplifying this we are getting tension in the string is T is equal to what? 2 m1 m2. Okay, carefully you have to observe equation number 1 ಮತ್ತು 2 ದಿಂದ ನಾವು acceleration ಅನ್ನು m2 minus m1 into z divided by m1 plus m2 ಅಂತ ಬರಿತಾ ಇದ್ದೇವೆ. equation number 1 ನಿಂದ acceleration ಏನು ಬರಿಬಹುದು? t minus m1z divided by m1 ಬರಿಬಹುದು. Similarly from equation number 2 ದಿಂದ ಏನು ಬರಿಬಹುದು? m2z minus t divided by m2. ಓಕೆ, ಈಗ ಟೆನ್ಷನ್ ಟಿ ಬೇಕಾಗಿದೆ. ಸೊ ಟೆನ್ಷನ್ ಟಿ ಬೇಕಾದಾಗ ನಾವೇನು ಮಾಡೋಣ? ಸಿ, ಈ ಒಂದು ಎರಡು ಈಕ್ವೇಷನ್ಗಳನ್ನು ಇಕ್ವೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಬೈ ಇಕ್ವೇಟಿಂಗ್ ದೀಸ್ ಟು ಈಕ್ವೇಷನ್ಸ್, that is t minus m1z divided by m1 equal to m2z minus t divided by m2. ಸೊ ಇವೆರಡು ಇಕ್ವೇಟ್ ಮಾಡೋದ್ರಿಂದ ಏನು ಸಿಗತ್ತೆ ನಮಗೆ? m1 c, by equating these two, because both are acceleration only, m2t t minus m1 m2 z equal to m1 m2 z minus m1 t. By taking t one side, m1 t plus m2 t equal to m1 m2 z. Take that m1 m2 z this side, again it is m1 m2 z, that is 2 times m1 m2 z. So therefore by taking t as common, we can write m1 plus m2 into t equal to 2 m1 m2 z, or t equal to 2 m1 m2 z divided by m1 plus m2. So this is the final derivation getting by solving these two equations. So here you have to take very carefully how to apply free body diagram. It is very important. Okay, thank you, and we can discuss the remaining terms in next class. Okay.